Chemist, and today we're going to look at a problem that I consider to be one of the more difficult chemical calculations problems. We are given a volume of a reactant, in this case gasoline. We are asked to find the volume of air required to burn it. So the question reads that a website claims it requires 10,000 gallons of air to burn 1 gallon of gas. Using octane as their chemical formula, C8H18, and the fact that air is 21% oxygen by volume, find the volume of air required to burn a gallon of gas at 0 degrees Celsius and 760 torr, which is normal atmospheric pressure. Take the density of gasoline to be 0.7 grams per milliliter. And we are given one conversion here, which is 1 liter is equal to 1.057 quarts. So in this particular question, we are given a balanced chemical equation, which is good. So for us, our first step is going to be to find the moles of gasoline from the gallon of gas. So if we are given 1 gallon of C8H18, we know that 4 quarts is equal to 1 gallon. And we know that we are given this conversion, 1 liter is equal to 1.057 quarts. So 1.057 quarts is equal to 1 liter. 1 liter is equal to 1,000 milliliters. Now, the reason we're going from gallon to milliliters is because the density given to us of gasoline is in grams per milliliter. So we have to get from gallons to milliliters. So once we get there, though, which we just did, now we can multiply by the density, which is 0.70 grams. And what that has done is gotten us from gallons of gas to grams of gas. And once we've gotten to grams of gas, we just divide by the molar mass of gas in order to find the moles of gas. So 1 mole, and if we add up the weight of C8H18, we find that it weighs 114.2 grams. So that if you multiply this through, you're going to see that gallons cancels, quarts cancels, liters cancels, milliliters canceled, leaving us with grams. Grams canceled, leaving us with moles. And that is going to give us 23.2 moles of C8H18. So the next step is going to be to find how many moles of oxygen are going to be required here. That's easy enough. We can just use our balanced chemical equation to find that. So if we had 23.2 moles of C8H18, from our balanced chemical equation, we find that for every 2 hexanes we burn 25 oxygens. And you'll see here that moles of hexane cancel out, and we're going to be left with moles of oxygen. And we multiply that through, we're going to find that we have 290 moles of O2. So because in this problem we were given a torr, we were given a pressure in torr, and we're given a temperature, and now we have the number of moles, and we're trying to find a volume of gas, we're going to have to use our equation, PV is equal to nRT, our ideal gas equation. But we're going to have to rewrite this equation to solve for V. So if we rewrite this, we're going to find that the volume of oxygen required to burn a gallon of gas is going to be equal to the number of moles of oxygen times R, a constant, times the temperature in Kelvin divided by the pressure. So we found that we had 290 moles of O2. Now, because our pressure is given to us in torr, we need to use the appropriate R constant. And for this case, you get this from a table, it's 62.36. Multiplied by our temperature, we need to convert from Celsius to Kelvin. It's 0 degrees Celsius, so to go from Celsius to Kelvin, you just add 273. So we have 273 Kelvin. And now we divide by our pressure, which was also given to us, which is going to be 760 torr. When we solve this, we find that we need 6496 liters of oxygen. So from the liters of oxygen, we need to find gallons of air. Now we know that air is not pure oxygen, so we're going to have to account for that in the next step. So now we want to find the volume of air, which is going to be equal to the volume of oxygen times. So if for every 100, for the 100% air, only 20% of it is O2. So we're basically dividing by 100. We're multiplying by 100 divided by 21, which is basically multiplying by 5. So if we do that and we come over here and take our 6496 liters of O2, and then we know that 100% air is only 21% O2, and we know that 1.057 quarts is equal to 1 liter. And now we know that 4 quarts is equal to 1 gallon. Now notice that we have liters of O2, and now we have O2 canceling out. So this is going to be liters of air. Now we're going from liters of air, liters over here canceling out, going to quarts of air, from quarts canceling out to gallons. And our final answer is going to be 8,172 gallons of air required to burn 1 gallon of octane. So given that it's not always 0 degrees Celsius outside, which is freezing point, I would say that this is a pretty accurate claim, because as the temperature increases, so does volume of gas. So as the temperature increased, let's say to 25 degrees Celsius, you would see an increase in the number of gallons of air required to burn gas. So that is how we solve this problem. Like, subscribe.